Hello students, I hope everybody is doing great. Well, I am your chemistry educator, Mr. Suryadilip Sripati. So today I am here to explain a very unique concept called as conjugation. It must be surprising to you guys, why did Sir choose the concept called as conjugation? Conjugation is one of those concepts in organic chemistry where there is a lot of misconception in it. Students easily fall into the trap or they have a very wrong misconception regarding this concept. I hope everybody is quite aware that what is the condition for resonance. If a compound has to involve in resonance, it should have conjugation. So what is this conjugation? You must have come across that conjugation is something which lies in alternate position. Is this concept technically right? Definitely wrong. So what is exactly conjugation? So let me explain you with utmost clarity. Conjugation means at least 3 p orbitals must lie in a single plane or on the same plane, which is considered to be coplanar. If minimum 3 p orbitals are on the same plane, then only we consider conjugation is present, else there is no conjugation. 1, 2, 3. So these 3 p orbitals must lie in the same plane. Then only we consider that conjugation is present. But 99.9% most of the times you come across that whenever there is a conjugation established with respect to the pi system, they usually lie in the alternate position. So that is the reason most of the times you easily get carried away that conjugation means lying in alternate position, but it is not 100% right. So let me explain you this concept in further more detail where conjugation can be established. Types of conjugation. In types of conjugation, you have pi-pi conjugation, pi positive conjugation, pi negative conjugation or pi lone pair conjugation, and one more is lone pair positive conjugation. If you have carefully noticed, the conjugation is most of the times with respect to the pi orbitals, and we have one more, that is lone pair positive conjugation. So let me explain you with pi-pi conjugation. Say suppose you have 1,3-butadiene. This pi bond, pi 1 and pi 2 are in conjugation. If I tell pi 1 and pi 2 are in conjugation, it means that the p orbitals are in the same plane. These p orbitals on each carbon atom, they are on the same plane. That is the reason they are in conjugation. This is the case of pi-pi conjugation. Pi positive conjugation. So with pi positive conjugation also it is the same story, where there is an empty orbital with a positive charge. So you have this p orbital and this p orbital are in the same plane with this empty p orbital. So this pi bond is in conjugation to this positive charge. Is that clear? Now you have pi negative or pi lone pair conjugation. So whenever you have a negative charge, definitely it will be carried or supported with a lone pair, and that's quite obvious. So these 3p orbitals are on the same plane. So that is the reason why delocalization is possible. So you would, why did you think ever why the orbitals must be in the same plane? Why the 3p orbitals must be in the same plane? Then only we consider in conjugation. So that once there is a bond shift or once there is a delocalization of electrons, then a new bond can be formed. For the formation of the new pi bond, you don't expect that the p orbitals must be in different plane, because in case of a pi bond, the overlapping takes place above and below the internuclear axis. So for that, both the p orbitals must be in the same plane. That is the reason why it is a necessary condition that for conjugation that the 3p orbitals must be in the same plane. So we have seen pi conjugation, pi positive conjugation, pi negative conjugation. Next, let us see lone pair positive conjugation. Say suppose you have an empty orbital on the carbon atom and you have a lone pair. So that means here with oxygen atom, where you have two lone pairs, the oxygen atom, one of the lone pair must be present in the p orbital, pure p orbital, and there is an empty orbital here. So this empty orbital will have a positive charge. The carbon will have a positive charge. So the positive lone pair conjugation. Is the concept clear? That means this empty p orbital and the lone pair is present in which orbital? Pure p orbital. And pure p orbitals, that means they do not involve in hybridization. Unless you are aware of the concept of conjugation, you can't really predict the hybridization properly. For example, if I ask you in this, the oxygen atom, what is the hybridization of this oxygen atom? Is it sp3? No. If you are telling sp3, that means you are conceptually not sound. You are not clear with the concept. Here, the hybridization is sp2. That means one of the lone pair is not participating in hybridization. That will happen only when the lone pair is present in pure p orbital. So have you got the concept of conjugation? So with the concept of conjugation, even the hybridization definitely will matter. And with the hybridization, in the coming sessions or in the coming topics, you will come across that how basicity will definitely affect. I hope so far whatever I have explained, it's a crystal clear to every one of you. So let me give you some more examples to understand the concept better. Before proceeding further, let me give you one more important golden point. Golden point is nothing but the key concept. That's it, guys. What is it? An atom can allow only one of its orbital to participate in conjugation. An atom will not allow more than one of its orbital to participate in conjugation. Only one it will allow. What does it mean? Say suppose if this is pi 1, this is pi 2 and say this is pi 3. You can't tell that both pi 1 and pi 2 are in conjugation to pi 3. You can't tell both pi 1 and pi 2 are in conjugation to pi 3. Either pi 1 is in conjugation to pi 3, or pi 1 is in conjugation, pi 2 is in conjugation with pi 3. Either pi 2 is in conjugation with pi 3 or pi 1 is in conjugation with pi 3. Either of them, not both of them. Just now, where I gave an example, lone pair positive conjugation, both the lone pairs will not be in conjugation with the empty p orbital. One of them will be in conjugation. Because only one orbital an atom will allow to participate in conjugation. Is that clear? Great. Chalo. This is a benzene ring. In this benzene ring, you have which type of conjugation? Pi-pi conjugation. To this benzene ring, if I have a positive charge, do you have positive pi conjugation? No. You will have only pi-pi conjugation, because an atom will allow only one of its orbital. The p orbital which is involved in the pi bond formation, that is in conjugation. So, the positive charge, the empty p orbital will not be in conjugation. Similarly, if I take aryl carbanion, here also you have pi-pi conjugation. Here you do not have pi lone pair or negative charge combination. Similarly, if I take aryl radical, here also you have pi-pi conjugation. You do not have pi odd electron conjugation is not present. Let me give you one more example. I hope you are aware of this name. This compound is nothing but pyridine. What is the hybridization of nitrogen in this? The hybridization of nitrogen in pyridine is sp2. When it is sp2? Only when the lone pair in nitrogen is not in conjugation. The lone pair is present in which orbital? Is present in sp2 hybrid orbital. That means you can give the exact hybridization only when you are aware of the concept of hybridization, concept of conjugation. So, this will definitely tell you whether the lone pair is available or not for donation. If it is not involved in resonance, definitely it will be readily available. But if it is involved in resonance, it will not be available. So, this is only what we compare as the basic character. So, I guess how the concept of conjugation also reflects some of the very, very important property of the compound. And let me wind up this session, guys, with one more classic example. cyclooctatetraene. It seems that the pi bonds are in conjugation, but the actual structure is something like this, a tub shaped structure. So, do you think in this it is in conjugation, the pi bonds? No. Why? Let be me more clear, guys. See, these two p orbitals are in one plane, these two p orbitals are in another plane. 1, 2, the third p orbital is in different plane. Here also there. 1, 2, 3. So, this is in different plane. Is that clear? So, that is the reason why this cyclooctatetraene is not considered to be conjugated. There is no conjugation. Is the concept clear? Correct. Excellent. So, I hope students you have understood the concept of conjugation. I have explained you how and why conjugation is important to establish whether a compound can involve in resonance or not. So, thank you so much. Please do not forget to share and subscribe if you have liked the content. Thank you so much. I will see you soon with the next video, guys. Please take care.